Alright, multi-area OSPF. Now you're excited for it, so looks like it might be a short one. First, we're going to explain why multi-area OSPF is used, explain how multi-area OSPF uses link state advertisements in order to maintain routing tables. This is going to be scary. Explain how OSPF establishes neighbor adjacencies in multi-area OSPF implementation, configure multi-area OSPF in a routed network, configure multi-area summarization in a routed network, verify multi-area OSPF. So, we've been doing single OSPF, single area OSPF, and what's the problem with it? The more routers we get, the larger the routing table, large link state database, frequent spanning tree algorithm calculations, right? So if one link changes, the entire thing has to change. And so to stop this, we do multi-area OSPF, because this is going to cause us, we're going to have to buy more expensive routers, and we're going to have convergence is going to be longer. And so we can split them up into these areas, and we know when we split them up to the areas, we finally get to talk about the backbone area, right? Area 0. And area 0, everything has to connect to the backbone if we want it to be able to route to the other areas, right? So if we want area 1 to go to area 51, it has to go through area 0. So, types of areas, right? So we have our backbone area, the transit area, where everything has to connect to, and then anything that's not in that is a regular area, or the stuff beyond this content, a stub area, total stubby area, or not so stubby area. It's CCNP stuff, but kind of hilarious. OSPF, whoever created this has to be, I don't know, I can't believe they passed it. Anyways, moving on, regular area, you know, it just feeds in between itself, and so now we have types of routers. So if you're just in your own area and not in any other area, you're not a border router, you're just an internal router. So as we can see, there's some internal routers right here. Then we have backbone routers. Anybody in area 0, just one interface has to be in area 0. That's how these multi-area areas work. Is one area is going to be area 51 on this router, one interface is going to be area 1 on this router, and the other ones are in area 0. Okay, so then we have area border routers, which are those routers that are in multiple areas, in area 0 and connecting another area to area 0. And finally, we have autonomous system border routers, which this one is because we probably have a static route to the internet, but if it went to any other type of autonomous system besides OSPF, right, or maybe an OSPF we didn't control, it would be an autonomous system border router. So EIGRP, RIP, if it's going into any other routing protocol, it's known as an autonomous system border router, because it's the border between the OSPF we control and something we don't. Feel free to do these activities. So now we have our awesome LSAs, right? And there's 11, but we only care basically about 5. We have type 1 LSAs, type 2 network LSAs, right? Type 1 was router, 3 and 4 are summary LSAs, and 5 are external AS LSAs. And so remember, these are the building blocks that they form the databases that build the routing table for OSPF. So these are like how we're building our SPF databases through these LSAs that are flooded, and this is how they are flooded. So first we have our type 1 LSAs, right? And our type 1 LSAs are flooded inside every internal area, right? So type 1 LSAs include a list of directly connected prefixes and link types. All routers generate type 1 LSAs. Type 1 LSAs are flooded within the area and do not propagate beyond the area border router. A type 1 LSA has a link state ID identified by the router ID originating it. Then we have type 2 LSAs, the network LSA. The type 2 LSA identify the routers and the network addresses of multi-access links. So as you can see, we don't see any type 2 inside of area 1, and that's because this is serial, so it would be non-broadcast multi-access, or it would be, actually, I'm not even going to say it's, that's not frame relay. That's just a straight serial link, so it's point to point, and so because it's point to point, there is no DR election. So DRs are flooding these type 2 LSAs. Okay, so type 2, right? Only a DR generates them. Type 2 LSAs are flooded within a multi-access network and do not go beyond the ABR. The type 2 LSA is identified by the DR ID. So now we have type 3. So type 3 is one of the summaries, and so type 3 is flooding basically what it's learned, right? So type 3 LSA describes a network address learned by type 1 LSA. Type 3 LSA is required for every subnet. ABRs flood type 3 LSAs to other areas and are generated by other ABRs. Type 3 LSAs link state ID is identified by a network address. By default, routes are not summarized. Alright, now type 4, the other summary. Type 4 LSAs are used to advertise autonomous system border routers to other areas and provide a route to the autonomous system border router. ABRs generate the type 4 LSAs. A type 4 LSA generated by the originating ABR and regenerated by others. So what it's saying is, hey, I got an autonomous system border router, and it's flooding that into the other areas so they can build their link state databases on that. Then we have type 5. Type 5 LSAs are used to advertise external, i.e. non-OSPF network addresses, and ASBR generates type 5. Type 5s are flooded throughout the area and regenerated by other ABRs. Type 5 LSAs, link states IDs, is an external network address. By default, they are not summarized, right? So it says, hey, we have the static route, and it floods it into the other networks. Anyways. Go ahead and do these LSA activities if you feel like it. Let's see. Types of OSPF routes. Okay, so these are how we learn them, is how they look, right? So the O, if we just see a simple O, that means it's within our area, right? Router 1, type 1, and network type 2 LSAs describe the details within an area. The routing table reflects this link state information with the designation of O, meaning the route is intra-area. Then we have OIA, which I always think of intra-area, but it's not. OIA summarize. When an ABR receives a summary LSA, it adds them to its link state database and regenerates them into the local area. When an ABR receives external LSAs, it adds them to its link state database and floods them into the area. The internal routers then assimilate the information into their databases. Summary LSAs appear in the routing table as IA inter-area routes. Oh, intra-area, that makes sense now. Sorry, read that wrong. And then our external LSAs, the routing table marked as external type E1 or E2. The difference with those is the calculation of the metric. So, but those are just external, meaning coming from the autonomous system, right? That'd be the type 5 ones. All right. So OSPF route calculation. Well, I think we could figure this out. First, we calculate the O routes, right, because that's inside our own area. Then we calculate the best path to the inter-area routes, the IAs, and then we get the non-OSPF routes. Implementing multi-area OSPF. Oh wow, this is not loading right. Anyway, so gather network requirements. Think about your IP designing plan. Figure out what you're going to name your areas, how you're going to divide them up, the network topology that is going to use to be connect them, and then configure them into the areas you want. Right. feel free to read over that more. But so look at how they're doing it down here. When we configure this, right, we configure it just like single area, except that when we type in this network address on the interface, we don't put area 0 in it. We put, so we're still in router OSPF 1, but see how we have both the backbone area and another area. That means it's a border router, right? So I think that's pretty easy to understand. Send me an email if you want an example of packet tracer on that, but yeah, you're doing it the exact same way. Then with IP version 6, similar. Instead of saying area 0, we say IP version 6.10 area 1 on the interface that is facing area 1, and area 0 on the interface facing area 0, and we're all hunky-dory. Feel free to try that out right there. So OSPF route summarization. So why do we summarize? Just like we did with static routes, we summarize to keep the routing table smaller. Okay, so normally type 1 and type 2 are generated inside each area and translated in type 3 and then sent to other areas. If area 1 had 30 networks to advertise, then have 30 LSA type 3 LSAs would be forwarded to the backbone. With route summarization, the ABR consolidates the 30 networks into one of 2 advertisements. So the type 3s become summarized rather than letting each network know. So we could do external. If we're coming from EIGRP, we could do external route summarization. Otherwise, it's those type 3s, inter area, so where we're just summarizing what each area is. And then we could, so this is probably, all we're doing is keeping less LSAs to be flooded and just making the routing table smaller with summarization, just like we did with static routing, route summarization. So how do we do it is the real question, right? Well, first we look at all of our routes that we need to summarize. So we have these OIAs, and 10.1.2, and we're going to break them into binary. And then we break them both into binary, and we write down where they last changed is our starting address, and how many bits we didn't use is our subnet, right? So this would be a /24, right? All those zeros. But now we have 2 more, and thus we have a /22 rather than a /24. So we have 10, 1, 0, 0, which we got from this into binary, right? Breaking these both into binary and seeing where they last are the same. That's where we get this number. And then what we have left over is going to be our subnet mask. Let me know if you have any questions on that. So then what do we do after we find that number? Well, we found the number, and so we type it into, we go into our OSPF, right? And we say OSPF 10, area 1, range, and type in that, what we just had. And so the range, on EIGRP we actually do it at the interface. On OSPF we do it inside the router OSPF. And so as we can see now, we have a OIA summary to our friends in the other networks. Give that a try if you want to. Actually, I think there is something. There is one thing you want to notice on the OIA, or not the OIA, on the O where we did the range command, our interface becomes null 0 rather than here it says where it's sent from, or where we're sending it out of, but on the where we're doing the range command, it actually sends it through the null, right? So when manual summarization is configured to prevent routing loops, right? We don't want to just spin around a circle. So if it comes back to there, we'll send it to that null and Bitbucket it, stopping the loop. Because those should be directly connected routes, right? We can't see because we're filtering for OSPF. But anyways, that's what it's doing. Our show command, similar to our exact to our single area one, so we went over that quite a bit in the last chapter. If you need a brush up, why don't you hit that video again, or just look through our next few figures. Yeah, show IP route, show IP OSPF database. Okay, now we have version 3, right? And so, are we just verifying? We're not summarizing, huh? Well, thank goodness we're not summarizing. So, once again, I believe that could be everything we have. Feel free to do some of these labs if you are not getting it. But basically, multi-area OSPF it just gives us more LSAs, right? Than we had before, and it allows us to converge faster, to have less resources. If one area goes down, it's only down itself, not the other areas, and we can summarize to make our routing tables even smaller, and basically it's just great. Let me know if you have any questions, or if you want me to do it, I can do it. Send me an email. I'll post a discussion. Thank you.